Here we're going to look at piecewise equations, and they start off with a review of what we've done before. So this whole first page, there's nothing new. So I'm going to show you the answers to the first page. And what you might notice, when you compare the cost of the two scenarios, the only difference in the cost is that the scenario 2 is always $10 more than scenario 1. And that's just because they have the $10 charge as their base charge no matter what. Okay, so you can pause the video if you need to, but I'm going to move on. Okay, so number 3, it says they use the new pricing model. And they start with, there's no base monthly fee, so that $10 they don't charge. And they'll charge 6 cents or $0.06 per kilowatt for the first 1,000 kilowatt hours, and then 8 cents or $0.08 per kilowatt for any amount over 1,000 kilowatts used. So the first several values are actually from the first example, where if they charge 6 cents per kilowatt hour, by the time you get up to 1,000, they're paying a total of $60. Well, then what happens is now you have to pay attention to the amount over 1,000 kilowatt used, because now they're charging 8 cents per kilowatt hour rather than 6 cents. So that 1,001st kilowatt hour, they charge $60, which is coming from the first 1,000 kilowatt hours, and then the 1 kilowatt hour they paid 8 cents for. So their total bill will be $60.08. So for 2,000 kilowatt hours, that 60 again is coming from the first 1,000 kilowatt hours, and then they paid 8 cents for the next 1,000. So again, that $60 already includes the first 1,000 kilowatt hours, and then they paid 8 cents for the next 1,000, for a total of $140. And then for 2,200 kilowatt hours, that $60 again is for the first 1,000 kilowatt hours, and then they paid 8 cents for 1,200. So to get from 1,000 to 2,200, that's another 1,200 kilowatt hours. So the total cost is $156. So at what value of X do our calculations become more complicated? We can see once you get to that 1,001st kilowatt hour, now the amount they're charging per kilowatt hour changes from 6 cents to 8 cents. So now that makes our calculation a little trickier. But hopefully nothing too crazy so far. Okay, so we're going to graph the relationship between X and B. So X is a number of kilowatt hours, so we have to fit up to at least 2,200. So that'll be your X value going across the bottom. And when I made the scale on this, what I looked at was there's about 24, I think there's 24 boxes going across. So if you let each box represent 100 kilowatt hours, then that works out fairly nicely. And then up the side is the total cost or the total bill. And the lowest amount was $0, and the highest amount that we had to plot was $156. So if you went up to maybe $200 or so, and what worked pretty nicely is if you use 10 for each tick mark. Okay, and then you plot the points. So there's the points plotted. And then if we look at what's happening here, if I use my ruler, notice the first 3 points that I plot is a linear equation. Hopefully I don't miss them at all. Okay, so we can see that the last 2 I plotted are not quite on that line. And the reason for that is after the 1,000 kilowatt hours, we were charged 8 cents per kilowatt hour rather than 6 cents. So that means your slope is going to be a little bit steeper after the first 1,000 kilowatt hours. So if I connect, hopefully I hit them. Okay, so that's what your graph would look like. Now it kind of looks like a line there, but we know that if I do place the ruler down, it's not quite a line, because the difference is the rate of change went from 6 cents per kilowatt hour to 8 cents per kilowatt hour. Okay, so if we move on to the next page, so for the first 1,000 kilowatt hours, the cost was B equals 0.06x. So again, there's nothing new there. So writing that equation is something we should have been able to do without a problem. However, writing the equation for the bill when x is greater than 1,000 kilowatt hours is a bit trickier. So once we got past 1,000 kilowatt hours, what did we do? Well, we know those first 1,000 kilowatt hours cost us 0.06 times 1,000, and that is where the 60 comes from. So we know those first 1,000 kilowatt hours cost us $60. So now the idea is, once we get past 1,000 kilowatt hours, we're going to pay for that first 1,000 using $60. And then it should make sense that if you use 1,001 kilowatt hours, the first 1,000 kilowatt hours were already included in the price of the first piece using $0.06 per kilowatt hour. So how do you calculate the price of 1,001, 1,002, 1,003? Well, the 1,001 kilowatt hours, we had $60 plus 8 cents once. That $60 represents the first 1,000 kilowatt hours. 1,002 kilowatt hours, we paid that $60 for the first 1,000, and then 8 cents for 2 more kilowatt hours. So $60, 16 cents. Okay, and then for 1,003, it's a similar result. So write an equation for the bill if more than 1,000 kilowatt hours are used. So if x is greater than 1,000. Well, if you look at what we did up here, didn't we take $60 and then add 8 cents per kilowatt hour times, this is the tricky part, it's not x. Because if x was 1,001 kilowatt hours, we didn't multiply 8 cents by 1,000. We multiplied it only by 1. If we had 1,002 kilowatt hours, we only paid 8 cents twice. So if we have 1,002 kilowatt hours, think about the x minus 1,000 would be 1,002 minus 1,000, which is 2. And I go through that, if that's confusing, which I understand how it could be, I went through that in this table. So if you use 1,000 kilowatt hours, how many kilowatts used over 1,000? Well, if you use 1,000, there was none over 1,000. If you use 1,001, you used 1 kilowatt hour over 1,000. 1,002, you used 2 kilowatt hours over 1,000. 1,100, you would use 100 kilowatt hours over 1,000. 1,200, you would use 200 kilowatt hours over 1,000. So notice what we're doing here is we're taking x. So as long as we're using more than 1,000 kilowatt hours, we basically want to know is how much are we paying, or how many kilowatt hours are we paying 8 cents for each. So if we have 1,100 kilowatt hours, we're paying 8 cents for 100 of them. 1,200 kilowatt hours, we're paying 8 cents for 200 of them. So how many kilowatt hours are we paying 8 cents for? Whatever our x value is, take away the 1,000. And essentially all you're doing is That 1,000 you've already paid for, so that's what you're taking away from the X. And again, this only applies, and this is extremely important, this is the whole idea of piecewise, which we'll talk about in a second, when X is greater than 1,000. That is when this applies. So, write the expression for the number of kilowatt hours we pay 8 cents per kilowatt hour is X minus 1,000. Okay, so we should notice that we're unable to write a single equation to represent the bill B if X kilowatt hours were used. This is because the rate of change is not constant. Okay, so we went from 6 cents per kilowatt hour to 8 cents per kilowatt hour. So that rate of change is not constant. However, we may write the total cost of the bill using two equations. To do this, we create a piecewise defined equation. Essentially, we can choose to represent the bill in two pieces. One for when X is less than or equal to 1,000, and the other piece for when X is greater than 1,000 kilowatt hours. Okay, so if we write the piecewise equation to represent the bill B of using X kilowatt hours, so if we use less than or equal to 1,000 kilowatt hours, that was your 0.06X. If we use more than 1,000 kilowatt hours, that was the second piece that we wrote, 60, which was the cost of the first 1,000, and then 8 cents times X minus 1,000. And we only use that if X is greater than 1,000. So there is your piecewise equation. So in number 10 on the next page, we're going to write that equation in simplified form. So we had this. We'll distribute the 0.08 to the X minus 1,000. So that gives us 0.08X minus 80, and we still bring down the plus 60. And then the 60 take away 80 is minus 20. So that's where that equation comes from. So our piecewise equation in simplified form, which that just means it's going to be easier to substitute values in for the X when it's simplified, is 0.06X if X is less than or equal to 1,000, and 0.08X minus 20 if X is greater than 1,000. So that is our piecewise equation. So this right here is just showing how to simplify that second piece to get at this. Okay, so when writing a piecewise defined equation, you cannot have the input overlap. In the above example, if we use a specific number of kilowatt hours, then we only use one piece of the equation. So the idea there is that the X values cannot overlap. So you transition from the first piece to the second piece once you get past 1,000 kilowatt hours. Okay, so in number 11, use that piecewise equation to evaluate the bill for the given X values for number of kilowatt hours. Okay, so you can take a minute and do that and pause the video and I'll show the answers. So notice for the 500 and 1,000, that satisfies the first piece of the equation. So you use 0.06X. So 0.06 times 500 and 0.06 times 1,000. For 1,200 and 1,450 kilowatt hours, those are greater than 1,000, so we use that second piece. So only substitute those values into the second piece. So you get 76 and 96 for those two values. Okay, I give you another example here. Suppose Jill and Bill are planning their wedding. The banquet hall gives them two options. So a base fee of $600 plus $23 per person. For option 2, they can charge $30 per person up to 70 people, and then $25 per person thereafter. So write an equation for each option if X people attend the wedding. So again, take a minute and try this. This is just a new example. Write an equation for option 1 which is easy, or should be easy, and option 2, which is a bit more difficult. Okay, and I'll give you a hint. Option 2 is going to be a piecewise equation. So pause the video and try it, and I'll show you the answers, and we'll talk about them really quickly. Okay, so option 1, pretty straightforward. Their starting value was $600, then they added $23 for every person. For option 2, 30x, that's $30 per person up to 70 people. So that you only use that when x is less or equal to 70. So then the idea is, if suppose 71 people come, well, those first 70 people you had to pay $30 for each. So that's $2,100. And then anyone over 70 that came, or not anyone over 70, any amount over 70, so we're not charging old people more. So any amount over 70 that showed up, you pay $25 for. Well, how many are you paying $25 for? Not for the first 70, that's included in the 2,100. You're paying $25 for x minus 70 people. So for example, if 72 people showed up, so if x was 72, 72 minus 70 is 2, you'd pay $25 for 2 people, and then $30 for the first 70. Okay, so there's your piecewise defined equation. Okay, the second part, determine the number of people that results in option 1 being cheaper. So one thing you can do, the longer way to do it, is use your calculator or just substitute in a bunch of values. And if 0 people came, option 1 would cost you $600 because that was your starting value. Option 2 would cost you 0 because 30 times 0 was 0. And then I just randomly chose some different values. And notice I put in 70 because that was the transition point here. When x is 70, that's when you stop using the first piece. And notice that option 1 is more expensive all the way up through 70. So then option 2 in that column, after 70, I'm using the bottom piece of that equation, or that second piece. So 100, you would do 2,100 plus 25 times 100 minus 70, and that gives you 2,850. So notice that that's $50 less. So option 2 is still less expensive. And then by the time you get 125, that is when they're equal. And then you can see option 2 is more expensive after 125. Now that's a long and tedious way to do it. Another way to look at it is, if x was less than 70, so if it turned out that option 1 was cheaper when x was less than 70, if you set those equations equal to each other, the option 1 equal to option 2. Now notice, I'm only looking at if x is less than 70 here, looking at that first piece. You get 85.7. That is when the options are equal. But the problem is 85.7 is past 70. So we would not be using that first piece anymore. We'd be using the second piece. We can't just say 85 or 86 people now because the price changed after you got to 70 people. So you take that option 1 equal to the second part of option 2. Now what I did there, I saved space and distributed 25 times x, and then 25 times negative 70. And then if you solve that equation, there's several ways to do this, but I subtracted 23x first, and then subtract the 350 from each side and divide it by 2. And you end up with 125, which notice is the same thing we got in the table. But if you can solve an equation, it's going to be probably an easier way to find that than using the table, because the table can be very tedious and take a long time to do. So option 1 is cheaper when x is greater than 125. So once you get past 125, option 1 will be cheaper. Okay, so that's a quick look at piecewise equations.